Welcome, Ryan. You are the only person here so far. We'll wait for more people to join.
All right.
Ryan, if you have any doubts, you can just ask. You know, because I don't know if more people
Sorry.
will join. Yeah, if you have any doubts, no, on the videos or anything about the course, you can just ask.
One second, your voice keeps breaking up.
So,
What? Just a
um,
second. Could you repeat that, please?
yeah. Can you hear me now?
Yeah, yeah.
Yeah. So, yeah, I was just saying, if you have any doubts about the course or the videos or anything, you can just ask because I don't know if more people will join. You know.
Oh, actually, I still had that sign-in problem until only yesterday. So only yesterday I managed to sign into the IIT website properly.
I
So I
see.
haven't yet seen all of the videos. So currently I have no doubts.
I see. Right. Okay.
All right.
Right. Yeah. Maybe wait for like 2 more minutes. I don't know if more students will join.
Uh,
Yeah. Okay, Ryan. So you're the only person here, and there are some students watching on YouTube, it seems. But I just assume like you're going to be the only one joining here. And since you don't have any questions, regarding the videos, maybe we'll talk about a few general questions.
All
Is that
right,
okay?
sure.
Maybe like,
Yeah,
yeah, maybe like 10-15 minutes. I don't know. Yeah, we'll see how
um,
long it goes. Yeah.
yeah,
Okay. So here is the question. So if I give you two finite sets, okay, two sets with finite number of elements, you'll be able to tell if they have the same number of elements, right? You can just count them. Okay, this has five
yeah.
elements. Set two has five elements. That's it, right? What if I give you two infinite sets? How do we think about their sizes? How do you think about the question of if they have the same size? Any ideas? Let's say you take the natural numbers, and let's say you take the even natural numbers. Okay, 1, 2, 3,
Yeah.
4, and so on. 2, 4, 6, and so on. Okay, you have two sets here. Both are infinite. Do they have the same size? Do they have the same quote and unquote number of elements? How do we go about thinking about this question? Any ideas? How do we compare the sizes of two sets if they are infinite?
Uh, um, okay, so uh, the first set is one, two, three, so on, right?
Yes, yes,
And the second set is only multiples of two.
yes.
So I mean, logically, it should be like half.
Mm-hmm, mm-hmm.
But
But
yeah, but like if it's infinite, if it goes on infinitely,
mm, mm,
you
like
could say, uh, uh,
like even half of a set is kind of a finite concept, right?
yeah, exactly. It's half
Mm,
of. I mean, infinity by two is still infinity.
exactly, exactly. So what do we do about it? How
So,
do we compare the sizes of two infinite sets? Do you know what a bijection is,
um,
Ryan?
no, what? Sorry,
Do you know what a bijection is?
bijection.
Huh.
No, I'm not
Okay.
familiar with that.
It's a simple thing. So uh, let's stay with finite sets for a moment, and let's say you have set A and set B. Okay, and I want to compare the sizes of set A and set B. What I will do is I'll take an element from A and I'll pair it with another element in B.
Yeah,
Okay. Now I have one pair. Now I'll take a different element from A and I'll pair it with an element in B. Now I have two
yeah,
pairs, right? I'll keep on pairing in this way. Okay. If at the end, when I actually can't do pairings anymore, if I all the elements of A and all the elements of B are exhausted, then they have the same
yeah,
size, right?
yeah.
Right. Now this pairing doesn't actually depend on the finiteness of the set, right?
No, I think like if you list them side by side, it would be say
Hmm.
1, 2, 3, 4, 5, and then it will
Hmm.
be on in set A, and then set B would have
Hmm.
2, 4, 6, 8, 10, right?
Hmm.
So
Hmm.
for one there's two, for one in set A there's two for set B, for two for
Hmm.
set A there's four for set B. So that will
Hmm.
both go on to infinity.
Exactly.
So
But every element in A will have a
yeah,
unique
it'll
pair
have
in B.
exactly the same thing in B. If
Exactly. So
yeah,
this makes sense when we want to compare sizes of sets, right? Even if we talk about infinite sets,
yeah,
right? And this is exactly how we mathematically do it. Okay, you have a set A and a set B, and there's a bijection between them. If we can do such a pairing, every element in A should have a unique pair in B, and all the elements in B should be paired with something in A.
it's just be like a horizontal line, right, between one and two,
Exactly.
two and four.
Exactly.
Yeah.
Exactly. But it is clear that these horizontal lines no, will actually exhaust all the elements in A and all the elements in B, right?
Yeah.
If you can
Yeah.
exhaust, if you can exhaust the elements of A and B through such a pairing, then there is a bijection between these two sets, and they have the same size.
Yeah.
Make sense? Makes sense, right?
Yeah.
Right. So that is how we compare to sets of infinite size. So the next question. Okay, so the natural numbers and even natural numbers are quite easy to understand. Let's take for
Yeah.
example natural numbers and all the integers. Do they have the same size?
Uh, so all integers, meaning like,
0, 1, 2,
yeah, so
3, and
starting
so
from
on.
zero, right?
No. 0, let me finish. So 0, 1, 2, 3, and so on. Minus 1, minus 2, minus 3, minus 4, and so on. All these numbers.
So do natural numbers and integers have uh, the same size, right?
That is the question.
Okay. Um,
Like, what do you think? Like, how do we go about finding a pairing? Now we know how to, if we suspect they have the same size, now we know how to prove they have the same size, right? Just find a pairing, correct?
oh yeah. So okay. So it'll be one in natural numbers will be negative infinity.
I mean, negative
Two will
infinity is
be,
not part of integers, no?
it is right. It's zero. It's negative infinity all the way to positive infinity, right?
Yeah, but negative infinity itself is not an element. It's not a number. It's not an element of the integers, right? Minus 1,000, minus 1 lakh, minus 1 billion. They are all integers. But minus infinity is not a part of the set of integers, right? It's not a number, first of all.
Oh, so you can't like cause
Hmm, hmm. But you are in the right direction. Like this is exactly what is causing a problem. Like you have two ends here. Before, in
yeah.
even natural numbers, you had only one end, and you could do the pairing. Now we have two ends. Now there's a problem. Okay, now we have to do something else to do the pairing, right? I think you can figure it out. Maybe take a minute. How do you do the pairing? Yeah. Only problem is, as you have observed, is you have two ends, right? How do you like circumvent that?
So they both have to start from zero. Um, so you could do one as a natural number paired
Hmm.
with zero as an integer, then
Okay.
two as a natural number paired with one as an integer,
Okay.
three natural number paired with two as an integer, all the
Okay.
way to positive infinity.
Okay.
And then
And
after
then
that, you do minus one paired with
minus
oh,
one. One.
okay, yeah, yeah.
Hmm.
It should both simultaneously reach n.
Hmm. Hmm. Yeah. So we
Um,
can't just do all the past. So now you can actually now you have realized that we can't just do all the positive integers first.
yeah.
So you have to mix things up.
Oh, okay, yeah. You can just do one zero, then one, then minus one. Oh, yeah,
Exactly. Exactly. And that will give you a pairing, right?
yeah,
One will go to zero, two will go to one, three will go to minus one, and they'll just after that just alternate. Two minus two, three minus three, four minus four, and so on.
yeah,
Right? So we are clear that it will actually exhaust all the elements, right? Of the integers,
yeah,
which means the natural numbers and all the integers have the same size,
yeah.
right? Now, what about? Can you tell me if the integers and the even integers have the same size?
integers and even integers.
Hmm.
Yeah, it'll be the same thing as the first one.
Yeah, just take a number and send it to its double,
Yeah,
right? Now we can notice that when it comes to an infinite set, a proper subset, okay, some subset inside it can have the same size as the whole set,
yeah,
right? That will never happen in a finite set. If you have a 10 element set and if you take a subset inside it, right, a proper subset inside it, that will have less number of elements from the whole set. But that is not what is happening in an infinite set. So fundamentally, when we look at infinite sets, it's much too different. Okay. So here's
yeah.
a question. Here's a question. On the same lines, what about natural numbers and rational numbers? You know what a rational number is, right?
Yeah, it's like a terminating decimal.
Are repeating, like 0.66666. That is also rational. Or you can just think of rational numbers as ratio of two integers, where the denominator is non-zero. 2 by
All
3,
right.
5 of 7, 9 by 10, and all that. Ratio of two integers such that, so you have a by b, right? Such that b is not 0. We can divide by 0, right?
Yeah,
So we exclude that case. That's it. It's all a by b such that a and b are integers and b is not a 0. That's it. That's your rational numbers. So you have now what? 1 by 2, 3 by 4, 100 by 1000, 1 by 12, 2 by 17, and all that. Okay, and minus of all these things too. And 0 is also a rational number because 0 is just 0 by 1.
yeah,
And all integers are also natural numbers. 2 by 1, 3 by 1, minus 2 by 1, right? Just divide by 1, you get all the integers also.
yeah,
Now you see what the set of rational numbers contain, right?
yeah.
Now the same question. So you have a lot of elements here. So do the set of natural numbers and the set of rational numbers have the same size?
Um, natural. Yeah, it will, right? Because it's the same
How
thing
is
as
that?
before.
What will be the pairing, for example?
Uh, Technically, rational numbers include one, two, three, and all, right?
Yeah, they do. They do.
Uh, so, I guess you could say one is
Hmm.
a fraction, like the lowest possible fraction, and then you go upwards.
Hmm.
I don't know how to explain it properly, but like a fraction that starts at a really small, uh,
I think you are on the right track. You are on the right track. Okay, so okay, let me make this maybe a bit easy for you. So one will be mapped to something, two will be mapped to something, three will be mapped to something, right?
yeah,
And so that's an order of rational numbers. The order is basically what is one. First number is what is mapped. One is mapped to. Second number is what is two is mapped to, and so on. That is the order,
yeah.
right? So maybe can you type maybe the first three four numbers in your order? That gives you the pairing, right? Naturally,
I mean, yeah, but I don't. How do you? What are the
exhaust.
first four rational numbers?
Exactly. That is what we have to decide. Exactly. How do we order them? How do we order all the rational numbers so that we will actually exhaust all the rational numbers like this?
Exactly. Uh, a rational number can be one variable over divided by another variable, whereas when both of them are not equal to zero, technically that's a rational number, right?
It is also a rational number, yes, but a can be
Yeah.
zero.
So, oh, okay, yeah, yeah. So a by b
Hmm.
is one is paired with a by b, and then two will be paired with a plus one by b. Three will be paired with a
Okay,
plus one by b plus one. Four will be paired with a plus two plus by. Oh wait, no,
but what is
you
a
can
by
do
b?
a by b is a rational number.
But what is a by b? Like, can you like one should be mapped to exactly what number? Also, uh, so you are just increasing first a plus b by b plus b, a plus 2 by b plus 2, and so on, right? These are not all the natural numbers, all the rational numbers, right? What about a plus 1
Yeah, yeah,
by b
yeah.
plus 10, right? Okay, so that is something for you to think about later. Okay, it's not uh, as trivial as the previous questions, but you will find it interesting, and I trust me, you will be able to find the answer yourself. Okay, it's not that very difficult, but yeah, it might take some time. Okay, Ram, good. Thank you for interacting. Uh, I'll put a different question here. Okay, in the chat.
All right.
Yeah, I have put the question there. So those who are watching on YouTube, next time everybody should be able to join on this meeting. Okay, I have talked to the team. Next time, all of you who wants to join the meeting on Zoom will be able to join the meeting. Okay, all of you will get the links, so that you can also interact here. Right. So the question, Yash Patil is also here. Thank you for joining. So in India, we know how a date is uh, our date system, right? March 2, for example, in this year will be written 2 3 2026. In some other countries it will be written 3 2 2026, right? Let's say you are in a country and you don't know what system they are following. How many dates in a year will be ambiguous to you in this 2 slash notation? That is, how many days in a year you won't be able to tell what day it actually is in this notation.
So it has to be within they both have to be under or equal to 12. So
Mm-hmm. Mm-hmm.
um
Can you tell me the number?
should be 144 days.
Can you take a moment? Just maybe.
It's a 132.
Is that Yash?
Yeah.
Yes, yeah. So why is it 132?
Okay,
You are
so
correct. You are correct.
initially both DD and MM have to be less than equal to 12. So you get 12 into 12, 144. And then you also have cases where
Right.
D like the you have like 1 1 2 2 3 3. In that case, even if you switch
Hmm.
them, it still becomes ambiguous. So we should remove those cases. So that's 144 minus 2.
Perfect.
That's 132.
Perfect. 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 That's it. That's it. Nice. Nice. Nice one. That's a simple question. Yeah. Uh, right. So now I'll post 4 statements. You have to tell me which one is wrong. Okay, I have posted the four statements. Tell me which one is wrong. There's only one which is wrong. I'll tell you that. And you have to tell me why that is wrong and why the others are right. So the statements are for the ones in, for students on YouTube. If 1 equals 3, then 1 equals 4. That is statement 1. Statement 2 is if 1 equals 3, then 10 equals 100. Statement 3 is if 5 squared is 25, then the number pi, right? Pi is 22 by 7. Fourth one is if pi is 22 by 7, then 5 squared is 25. Which one of these is wrong?
Is only one of them wrong?
Yes, only one of them is wrong.
No.
Any ideas? Any thoughts?
I think the first one is wrong.
Why is that?
Uh, because even if you were to assume that 1 is equal to 3, then
Hmm.
if you say 1 is equal to 4, it's completely contradictory. Whereas if you assume 1 is equal to 3, then 10 is equal to 100 is a different thing altogether.
Okay. So, hmm, so if 1 equals 3, then 1 equals 4. That means, so you have two statements. If A happens, then B happens, right? If this is wrong, then what do you have to demonstrate?
Uh,
You have a statement like if A happens, then B happens.
yeah.
Like if it rains, then I'll run. If it is wrong, then to prove it is wrong, what do I have to demonstrate? If it rains, then I'll
To
run.
prove it's wrong, you need to prove 1 is equal to 3. Once you when you're proving A, you find out that B is false.
No, so basically, the statement says if A happens, then B happens. To prove this is false, what do I have to demonstrate?
Uh,
Let's say, the statement is if it rains, then I will run. If you wanted to prove this wrong, what do you have to demonstrate?
Wait, is it that the if statement should be correct, but the then statement should be wrong?
You are very close, I think. Basically, yeah, essentially. But again, the gist of what I'm trying to say is, you have a conditional statement, right? Conditional mathematical statement. If A happens, then B happens. If you think this is wrong, then what do we have to demonstrate to prove this is wrong? What do we have to demonstrate?
to B first.
Not quite. No. See, it has to do with like both the statements, right? If A happens, then B happens. If this is false, then what should happen?
It's false and B shouldn't happen in the first place.
Uh, I don't know if you mean what I think I'm meaning. Like, for example, if it is false, then what happens to A? If A happens, then B happens. So this is basically an implication, right? If it is false, then the implication should not be happening, right? So to demonstrate it is false, I should basically demonstrate even if A happens, B may not happen, correct? So
Yeah.
basically I have to demonstrate, for example, even when it is raining, I won't run, right? But
Yeah.
to demon right, so now here A has to happen, right? If I wanted to prove it is wrong, A has to happen. I have to prove even if A happens, B doesn't happen. But for that, I need A to happen first. Correct? You get
Yeah.
me? So if A never happens, then I can't prove it is false. If A never happens, A is a situation that never happens, then there is no possible way for me to prove this implication wrong, right?
Yeah.
Right? Now can you tell me the answer? And Yash Patel, I think this is what you were talking about. Maybe I've just told you a bit more precisely. Yeah, your answer was three, right?
Yeah. Like,
Yeah,
yeah, three.
yeah. So now can you tell me, for example, what I just told, through what I just told, why the other three options are correct? Option one, option two, and option four. Can you guys see why, for example, uh, option four is correct? I mean, option four correct means the statement in option four is correct. You guys get me right? Should I reiterate or something?
Oh no, I think I got because 5 square is equal to 25 is true. Um, Pi is equal to 22 by 7 is
False,
yeah, exactly. So that's
right?
why it's valid.
Exactly. So, for example, what about statement four? What is happening there?
Is it like pi is equal to 22 by 7 is false?
Yeah, it is false, right? It is not
Yeah.
22 by 7. Yeah, it is
Yeah.
first of all an irrational number.
Yeah.
So there, it says A happens, then B happens, but A is false always.
Yeah.
So we can't prove the implication is false. So the statement four is true,
Yeah.
right? Same way we can say statement one, statement two are also true.
Yeah.
So statement three is the only one that is false, right? Okay, right. So I think we can end the session here. Hopefully, in the next week we have more people to interact with, more things to discuss. Okay, and yeah, if you guys, I'll stay here for a minute or more. If you guys have any questions, anything to ask, any feedback, I'll be here.
Are you a student or a professor?
I'm a scholar. I'm a researcher here.
Oh, all right.
Yeah, right. So Yash Patel, you have chess on your profile picture. Hopefully, you
Yeah.
are liking the videos so far.
Yes, sir.
Yeah, yeah, yeah.
I
Yeah.
had joined through YouTube, but then I got to know that there's a Zoom session, so I
I
joined
see.
through Zoom.
I see. I see. I think uh, all of you will get the Zoom link from next week, and it's better if you guys join on Zoom because we can actually interact, right?
Yeah.
That's much better. Yeah. Right then. So we'll call it a day.
All right. Thank you.
Right.
Thank you so
Thank
much.
you. Thank you for joining. Thank you for being interactive. Thank you.
Thank you.